Okay, so I wanted to give you a few examples of the Pythagorean theorem in action. So I'll give you a second to work on this one, see if you can find the length of the missing side here. So go ahead and give the video a pause and see if you can do it on your own. I'm going to go ahead and work out my solution. So the Pythagorean theorem says that leg squared plus leg squared equals hypotenuse squared. So in this case, I can say that 3 squared plus 4 squared equals the hypotenuse squared. So 9 plus 16 equals h squared. That means 25 equals h squared. And then we take the square root. And one of the things that we talked about when we were doing some work with algebra is that really when you have an equation like h squared equals 25, you have two solutions. You have a positive solution and you have a negative solution. In this case, since we're talking about a side length, we're going to be taking the positive solutions every time pretty much. There may be some application problems when for one reason or another we take the negative solution, but in geometry we're usually dealing with positive values because we're talking about a side length and it doesn't make sense to say that something is negative 5 inches long, right? So in this case we'd say h equals 5. I didn't give us any units. If these were inches, then h would be 5 inches, right? Okay, so there's that one. Pretty straightforward. Let me give you another one. This time, let's find the perimeter. Let's see if we can find the perimeter of this triangle here. So we'll call it 12 centimeters, 13 centimeters, and this side I'll leave blank. Okay, so go ahead and give the video a pause and see if you can figure out the perimeter of that triangle. Okay, so here's my solution. Obviously, in order to find the perimeter, we need to find the missing side first. And to find that missing side, well, we're going to have to use Pythagorean theorem, right? One place, if you are working on this, a common mistake for students is that they'll say something like, oh, well, going off their last example, right? They might say, well, here we said 3 squared plus 4 squared equals missing side squared. So maybe here we should say 12 squared plus 13 squared equals this side squared. That would be wrong, right? Because the Pythagorean theorem says a squared plus b squared equals c squared. C has to be the hypotenuse though, right? C has to be the hypotenuse. This is the hypotenuse of our triangle. So the correct way to, actually maybe I'll write out the incorrect way. So the incorrect thing to have done would have been to say something like, maybe I'll call this a. So it would have been to say a squared plus, or sorry, that's the correct thing to do. The incorrect thing to do would be to say 12 squared plus 13 squared equals a squared, right? That's not true at all. The correct thing to do would be to say that a squared plus 12 squared equals 13 squared, right? Leg squared plus leg squared equals hypotenuse squared. Okay, so that means a squared plus 144 equals 169. And then you can subtract 144. So a squared is 25. And then you can take the square root. So a is 5. Oh, we got 5 again. That's okay. That's not our final answer, actually, because we were asked to find the perimeter here. And all we've done is found this missing side. So we have a little bit more work to do, right? We could say, okay, so then the perimeter is going to be 5 plus 12 plus 13. Which comes out to 30. Okay, so 30 centimeters is the answer to that one. Okay, once again, not terribly difficult, but I want to do one from the book that I thought was kind of fun, a little bit more challenging. So this is on page 94 of your textbook. It's page 94, so it's investigation 41, and I want to do part B on that investigation. So, so this is page 94, right? It's investigation 41, and it's part B that I'm wanting to look at. So here's the picture on part B. I'm probably going to give you parts A and C for homework, right? But looking at part B, it says find the value of x in the following figures, right? So I'll let you pause the video, take a look at this one. Note that 11 is not the length of this entire side from this corner to this angle right there. 11 only goes from this spot to this spot, right? So go ahead and give the video a pause and see if you can work this one out. Okay, I'm gonna work out my solution now. Maybe I can just trace this thing. Yeah, this is kind of nice. I'm gonna trace this so that I have a decent picture to go off of. That is, if I could even trace well. 11, 10, 6, and x. Okay, so here's a picture. If you said something like 6 squared plus 11 squared equals x squared, that's wrong. Sorry to break it to you, but that was wrong. Because again, the 11 doesn't correspond to this entire side, right? The 11 only goes from here to here. So in order to use the Pythagorean theorem on the big triangle, first we need to figure out what this side length is so that we know what the entire, the total side length is, right? Now, we can do that if we use the Pythagorean theorem on the little triangle, right? So we can say, if we give this thing a name, maybe I'll call this A. So if we call this A, then we can say 6 squared plus A squared equals 10 squared. Right, so 36 plus A squared is 100. We can subtract the 36. A squared is 64. Take the square root, right, and you get A equals 8. So now we know that that side length is 8, which means that the total side length would be 8 plus 11, so 19. Okay, and so now we can apply Pythagorean theorem again. We can say 6 squared plus 19 squared equals x squared, right? Oh, and I don't have 19 squared memorized, so I need my calculator. My wife's laughing at me again. She's laughing because she expected me to have 19 squared memorized. She has a very high opinion of me. Yeah, that's not important anymore. That was a different video. Okay. So 19 squared is 361. 6 squared is 36. And 36 plus 361 is 397. So x squared is 397. And that's not a perfect square, I don't think. So you're not going to get a pretty answer out of this, right? Your answer is just going to be, you know, x is the square root of 397, whatever that is, right? But that would be your exact answer. If you wanted to get an approximation, you could change that into a decimal on your calculator. And it's about 19.9. You could give more decimal places than that if you want. But But now's as good a time as any to point out that this answer here, the square root of 397, that's the exact answer, right? That's the exact answer. That's exactly the correct answer. 19.9, students tend to prefer these kind of decimal numbers, but that's not the correct answer. That's almost the correct answer. It's close to the correct answer, but it's not actually the correct answer, right? This is an approximation. And you'll notice that when I wrote down the answer, I used an equal sign here, but an approximation sign there, right? Little squigglies, right? So x equals the square root of 397. That's about 19.9. But if I asked you on a test or a quiz for the exact answer, this is the one I'm looking for, right? I want you to give me the square root of 397. If I say, now approximate the answer and round the answer to one decimal place, well, now this is the one, this would be appropriate, right, at that point. But if I'm looking for the exact answer, then this is the one I'm looking for. As you're going through the homework, it would be good practice for you to just give both. Just get into the habit of doing both versions, right? Write down the exact answer, and then also write down the approximation, and make sure to use a squiggly, a little approximation sign instead of an equal sign, because this number does not equal that number. They're approximately the same, but they're not exactly the same. And that's that, right? So that's the value of x on that problem.